Okay, hi everyone. Today we are going to discuss about robotic control systems. We know that robotics is an interdisciplinary area of study between engineering and computer science. The key aim of robotics is to produce computer programmable machines that can do tasks with more speed and precision. The applications of robotics is countless in the current era. For example, transporting heavy things and logistic management, automated manufacturing, self-driving cars and unmanned aerial vehicles, and many more. It is necessary for every beginner to understand the concept of control systems to get started with robotics. In control systems, it helps to control the movements and functions of the robot. To understand the control system, we need to understand some terminologies used in robotics. Okay, first one is state. Here we have state. A state is an uh, it is a state is a model, or it is something new beginning. Okay, it is the output produced by a robotic system is known as a state. Normally we denote it as by x. The state depends on its previous states, stimulus, that is signals applied to the actuators, and the physics of the environment. The state can be anything: a pose, a speed, velocity, angular velocity, force, and etc. Next one is estimate. Robots cannot determine the exact state x, but they can estimate it using a sensors attached to them. These estimations are denoted with Y. It is the responsibility of the robotic engineer to select good enough sensors or to calibrate the sensors well, such that they can produce Y and X. And we have a reference, the goal state we wish to achieve. It is denoted using R. And we have error. The difference between a reference and estimate is known as error. Next one is control signal. The stimulus or the signal it produces output by the controllers is known as control signal. It is denoted using U. And we have dynamics. It is also called as the system plant or system model. It denotes how the system will behave under non-static conditions. Dynamics are affected by the environment that may change or not always linear. For example, floor type, concrete, wood, and the air drag, slope, and etc. It is always the key responsibility of a system to build a controller that reacts and produces control signal U, such that error signal and reference signal. Okay, and we have to know the parameters used in robotic controllers and what that parameter does. First thing, uh, it estimates the speed of your robot is the state, and estimate the current speed from the preferred sensor, for example wheel encoder, like that. And the speed you wish to achieve is the reference, that is R, and error is simply the difference between R and Y. And we have a voltage that is produced by your controller to increase or decrease the speed is your control signal. And the environmental characteristics like friction and air drag may affect the dynamics of a system. And also we have to design our system accordingly. Okay, a robot can have one or more controllers for various purposes. For example, one controller for cruise control and another control for controlling the linear motion of the robot hand, and one for rotation movement for the hand, etc. We need the controllers because the dynamics system plant vary with the time, such as when the robot moves up in a slope and then down in the slope, or first travels on smooth concrete, then on carpeted floor. So the best way to design a controller is by understanding the physics of the environment well. It will help to list out the elements that needed to be considered in controller design. Okay, and here we have some requirements, like the controller should reduce the error closer to zero. Error should be zero, and it should bring the estimation to the reference Y to R. They need to be robust. They should not depend on things we don't know. If there are any changes in the robot's environment, they should be able to adapt it, and they must be stable, meaning they should not go out of control. They need to be smooth in their movements, and the controller needs to be responsive. It should be fast enough to get the output reference level within a satisfactory time. And we give our reference state to a controller. We know that the controller also has a sense of feedbacks, and using a reference state and sensor feedback controller, it generates a control signal needed to reach the reference state. This control signal is fed to the system. The system dynamics determine how the system behaves to this controller input. If the controller is good, hopefully the system will reach our desired reference state. Thank you.